Howdy, this is your friendly neighborhood physics teacher here, and we're going to talk about your collision calculations. We're going to talk about collision calculations. So the first collision calculations we're going to talk about is your elastic collision. So hopefully by now you know elastic means they bounce off. So your elastic equation is going to look like M1 VI1 plus M2 VI2 equals M1 F1 plus M2 VF2. So you have two objects, and this is before the collision, and this is after the collision. Before the collision, after the collision. So you can kind of think about it as you have a block here, you have a block here, they're going towards each other. The collision happens, and then after they hit, they kind of bounce off of each other. So what's happening right here, you think about the hit. So we'll do just a little small version of it. So all they're doing is they're just running into each other. So this is block 1, that's block 2, block 1, that's block 2. So this is the hit. So before, the hit, after. Now just a reminder, M is your mass. It's measured in kilograms. It's measured in kilograms. It's represented with a kg. Your VI stands for initial velocity. And it's measured in meters per second. The M's still mean mass, but your VF stands for final velocity. And again, it's measured in meters per second. So in the 1s and the 2s just tell you what block you're dealing with. So that's the equation. So let's put some numbers to this, shall we? So before the collision, we're going to have block 2 just sitting there. Block 2's mass is going to be 10. We have block 1, which is moving. Block 1's mass is going to be 20, and it's going to be moving at a velocity of 5 meters per second. And then block's 2 initial velocity is going to be 0 because it's not moving. So that's going to be the before, the before. The after So after the hit, the mass of the block does not change. So the mass of the block is still going to be 20 for block 1 and 10 for block 2. Now the initial, or the final velocity of block 1 is going to go to 2 meters per second. And we want to know the final velocity of block 2. So that's our unknown. So again, we're just going to go back to our equation. So the initial velocity plus m2 initial velocity equals the final velocity. And we just plug in what we have. So we have 20 times 5 plus 10 times 0 equals 20 times 2 plus 10 times what we're looking for. So the first thing I would do is simplify these little sections. What do I mean by little sections? Like I would simplify that, I would simplify that, I would simplify that, and you can't simplify that. So 20 times 5, this gives you 100, plus 10 times 0 gives you 0, equals 20 times 2 gives you 40, plus, and then this has to stay like this because it cannot simplify. Now you can simplify again. You can simplify that. So 100 plus 0 is just 100. So 100 equals 40 plus 10 times your VF. You cannot simplify the blue side. The reason is because of that VF. So we need to get the 40 on the other side. It's being added. The opposite of adding is subtracting. What you do to one side, you got to do to the other. So 100 minus 40 gives you 60 equals 10 VF. You want the VF by itself, it's being multiplied. The opposite of multiply is divide. And what you do to one side, you got to do the other. So you get that your final velocity is 6 meters per second. So there you go. Really? Please stop. There we go. I'm trying to shrink it for you and it's not wanting to shrink. Okay. So there we go. So kind of breaking down, this is the elastic collision. This is an elastic collision. So let's talk about an inelastic collision. So an inelastic collision. Now an inelastic collision, you can think about it that it sticks together. So inelastic collision sticks together. So how the equation changes, the beginning is the exact same. You have your block 1, your mass and your velocity. Block 2, mass and velocity. So it's the second part that changes. Since they stick together, they're going to have the same velocity. So you only have one final velocity. So again, you have the before and you have the after. So before and after. M still stands for mass, VI still stands for initial velocity, VF still stands for final velocity. So all the descriptors still stay the same. So if we're going to draw out a little example again, so we're going to keep everything the same, just except for the ending. So this is the before. We have block 1, block 2, and then, so block 1 is still going to be 20 kilograms. with initial velocity at 5 meters per second. Block 2 is still going to be 10 kilograms with initial velocity of 0 meters per second. After the hit, the two blocks are going to stick together. Block 1, block 2. And they're going to move together in the same direction. So block 1 is still 20. Oh, pins. Block 2 is still 10. But we want to figure out what the final velocity is going to be. Now remember, this is before the hit, so the hit does happen in here, and they just hit. But unlike the elastic where they bounce off, they stay together. So if we were going to, again, do this in our equation, mass 1 times VI1 plus mass 2 times VI2 equals mass 1 plus mass 2, because they stick together, final velocity. Well, we can just plug in what we got now. So 20 times 5 plus 10 times 0 equals 20 plus 10 VF. Now at this point in time, we just got to simplify. We can simplify that. We can simplify that. We can simplify that. So again, 20 times 5 is 100, plus 10 times 0 is 0, equals 20 plus 10 gives you 30, V final. We can simplify one more time. Oops. We can simplify this. 100 plus 0 is still just 100, equals 30 VF. We need the VF by itself, so we need to move the 30 over. The 30 is being multiplied. The opposite of multiply is divide. So you get that your VF equals 3.33 meters per second. There you go. So there's how to do an inelastic. So they just stick together. And there's how to do a elastic, where they bounce off. So hopefully that helps. If you have any questions, don't be afraid to ask Miss Verona or Miss Heath. Have a wonderful rest of their day. Bye.